An outlier is an observation that does not fit the rest of the data. It is very different than most of the values. Outliers are sometimes called extreme values. They're extremely high or extremely low. Here's an example of a histogram with an outlier. Notice the outlier is located around 200, so it is extremely higher than most of the data values in the set, which fall below 50. This is another example of a histogram with an outlier. Now here the outlier is not as obvious because the outlier is around 15 as opposed to the rest of the data values which fall between 0 and 10. So because of the fact that we can't always tell outliers just by eyeballing the data set, we use a specific calculation process to help us determine outliers. A value is suspected to be an outlier if it falls below the lower bound or above the upper bound in a data set. So this is what we calculate to help us identify outliers, the lower bound and upper bound. And we use these formulas to help us. The lower bound is Q1 minus 1.5 times the IQR. The upper bound is Q3 plus 1.5 times the IQR. The reason for this is because remember what IQR represents. It's the middle 50% of the data. And Q1 and Q3 fall on either ends of this middle half of the data. So the lower bound and upper bound helps us identify if a value is just way too far away from most of the data. If it is way lower than half of the data or way higher than half of the data, that means it's way too different and would be considered an outlier. And remember, to determine the IQR, you subtract Q3 minus Q1. We're going to complete two different examples. In the first example, we will determine if this data set has an outlier, and we will use GeoGebra to help us. Here's the data from example 1, which I've entered in column A. I'm going to highlight my data, click on the histogram, click one variable analysis, show statistics, and here I have Q1 and Q3, which will help me calculate the outliers. Q1 is 57.5 and Q3 is 79.5. Here are Q1 and Q3, which we just determined from GeoGebra. And to calculate the IQR, I subtracted the two values and came up with 22. Now remember, this is the formula for the lower bound. I simply have to plug in Q1 and the IQR. So I plugged in 57.5 and 22. Then I perform the multiplication. 1.5 times 22 is 33. Then I subtract, and that tells me my lower bound, which is 24.5. Remember, this is the formula for the upper bound. This time I plug in Q3. I don't have to calculate 1.5 times IQR again because I already did that. Remember, that was 33. And Q3 was 79.5. So I add these values, I get 112.5. That's my upper bound. Remember, once I find my lower bound and my upper bound, this is how I determine if there's any outliers. Outliers will fall below the lower bound or above the upper bound. If I look at my upper bound, 112.5, there's no values in this data set that falls above that number. But I do have a value falling below the lower bound. That value is 24. 24 falls below 24.5. So this data set does have an outlier. The outlier is 24. It is an outlier because it falls below the lower bound. Let's look at another example. Again, I'm going to use GeoGebra to determine if this data set has an outlier. I've entered the 24 data values into GeoGebra spreadsheet in column A. I'm going to highlight the values, click on the histogram, one variable analysis, show statistics, I see Q1 is 6.7, Q3 is 18.25. Here are Q1 and Q3. I subtract these values to get the IQR, which is 11.55. Remember, this is the formula for the lower bound. I plug in Q1 and the IQR, and then I perform the multiplication. So I multiply 1.5 times 11.55. I get 17.325. I subtract this from Q1, which was 6.7, and I get my lower bound, which is negative 10.625. It's okay if your lower bound is negative. It doesn't mean it's incorrect. Here is the formula for the upper bound. I'm going to plug in Q3 and plug in the calculation I came up with when I multiplied 1.5 times the IQR. Remember, that calculation was 17.325 and Q3 was 18.25. So I add these values together and I get the upper bound, which is 35.575. Now I look at my data values and I determine, do any of the numbers fall below the lower bound? And none of the numbers do, because all of these numbers are positive. Then I determine, do any of the numbers fall above the upper bound? None of the numbers do, because my highest value is 24. So that means there's no outliers. This data set does not have outliers because none of the numbers fall below the lower bound or above the upper bound.